To start our studies in linear motion, quick reminder about scalars and vectors. A scalar is a quantity that has a magnitude but no direction. A vector is a quantity that has magnitude and a direction. You have to be sure you know which one you're talking about because it will give you different answers, as you're about to see. So let's begin. First, we talk about position. When we're talking about position, there are two basic quantities: distance, which is a scalar, and displacement, which is a vector. Distance, which we use d for, distance is the total length of the pathway taken, measured in meters. Displacement, which we use an s for historical reasons. Some people do use an x here rather than an s. Displacement is a vector that describes the location of the destination relative to the origin. So distance is how far you travelled, but displacement is how you got to your final destination from where you started. Distance is a scalar and displacement is a vector. Let me show you the difference with an example. Mitchell walks 400 metres down the road to the shop, then walks back again. Well, the distance is the total distance that he travelled. He went 400 metres there and 400 metres back, which is 800 metres in total. But the displacement is how far he is away at the end from where he started, which is 0. He has no final total displacement because he's at the same point at the end as where he started. Can you see the difference? Distance is a scalar, how far did he actually travel? And displacement is how far is he at the end from where he started. Now, because it's 0, we don't even have to give a direction. Here's a more complex example. Jenny walked 4 kilometres east and then 7.5 kilometres north. Well, the distance, again, is just the total length of the path travelled. 4 kilometres east plus 7.5 kilometres for the north for a total of 11.5 kilometres. Distance is a scalar. But displacement is a vector. It's harder to calculate. So, let's draw a diagram. She's walked 4 kilometres east and then 7.5 kilometres north. I actually want to find out, let me find another colour. I actually want to find out this. That's the displacement. So I can work out its length with Pythagoras and then its angle with tan. So let's have a go. Whoopsie. I want to use blue. So the length of S, that's standard mathematical notation for length, is the square root of 4 squared plus 7.5 squared. Now, if you get your calculator out, you should find that's 8.5. I happen to know that one. So that's 8.5 kilometres. The angle is inverse tan of 7.5 opposite over 4 adjacent. Now, yes, you could use the length you just calculated and either of those and use trigonometry, a different way to get there. But if you do that, you run the risk that this calculation is not right. Always preferable to use numbers in the question if you can. Well, if you get your calculator out, you should find that's more or less 62 degrees. Now, it's just under, but given the numbers in the question, 1 and 2 significant figures, I don't think there's any justification at all for giving more than 2 significant figures here. Okay, 62 degrees. So my displacement is actually 8.5 kilometres. At what angle? Well, that's north and that's east. So what we can go is east 62 degrees north. Or you could give this as a proper bearing, which is the angle clockwise from north, which will be 90 minus 62, which I think is 28 degrees. This is perfectly good enough for this kind of answer. But notice it's got to be a vector.